Hey guys, it's your heat sink here. Remember me? I really do a better job when you clean me out. So, you got a can of air? Oh, okay, loading Microsoft Word. Guys? Hey, listen, we talked earlier about cleaning the heat sink, but I don't think you got the memo. I'm really dirty. It's getting hot. Really hot. Okay, opening up Internet Explorer. Oh. Guys, I don't know if I can take much more. I really could use a cleaning. Guys, can you hear me? Okay, loading League of Legends.
Whew, that's better. Hey, while anything that uses electricity generates some heat, there's no other piece of hardware in our PC that generates more heat than the CPU. And keeping those temperatures under control is one of the keys to a system's longevity. So let's beat the heat and learn all about CPU cooling. Now, first of all, you may be wondering, why do I have to keep my CPU cool? Well, you get it clogged up, those fans stop moving, those heat sinks get clogged up, and you're going to experience overheating. Overheating leads to system instability, and you may encounter some intermittent shutdowns as well. It's very important to keep that airflow going in your case, keep your fans moving, keep your heat sinks clean. Now, this is a heat sink, and these are really neat. If you look at them, they have a wide base here, several pipes on this one that lead to a bunch of fins. And so the idea here is that we make as flush of contact as possible with a CPU, and we use some thermal paste that helps us do a thermal transfer to all these fins, and then we have the fans that actually push air through here and actually suck the heat out. So it's kind of passively transferring here, and the more surface area we have, the quicker we can cool. So heat sinks are really neat, and they come in a couple different types. There's, this is a multi-fin one, obviously, and a multi-pipe one. They make them in copper round pins and elliptical fins and all these cool ones, but these are pretty much kind of the standard ones you're going to see. This is one that comes directly with a CPU. In fact, this exact Intel CPU right here, and you can see Intel knows what they're doing, but it's a small heatsink, small fan, and depending on what you're going to use the CPU for, you might, need to upgrade to something third-party or aftermarket. So, cool stuff, heatsinks. Now, fans, we touched on this in another episode, but we have a bunch of different fans in our computer, in our PC, and a bunch of different sizes. Now, most fans used in PC cooling are about this size, about 180 millimeters. Some are a little smaller. You can get all the way down to 120 millimeters. But the 120 millimeters is generally considered the workhorse and general purpose cooling, while something like this is what you're more likely to see in moving case cooling, like these here on the side. Now, let's talk about my favorite thing, thermal paste. Thermal paste. So, on the market right now, I think there's about 5 types, and if I remember right, silicone-based, ceramic-based, carbon-based, metal-based, and liquid metal-based. Although I haven't had a chance to get my hands on some liquid metal-based yet. Typically, most thermal paste you're going to find is something similar like this, or your Arctic MX4, which is an industry favorite, an old standard. They come in small little tubes like this. You can get them something bigger. They're just a silvery metal thing, and honestly, can we get a shot in on that? If you take a look, this, I know to our eyes, looks like a flat surface, but you can barely make out. There's some scratches all along there, and there's a lot of imperfections. And even if these scratches weren't caused by us, even just straight out of the factory, this integrated heat spreader that's built into the CPU on the top, technically the lid, and this block, the base of the heatsink, actually have millions and millions of little imperfections in there. And so the goal when we apply thermal paste isn't to make this huge sandwich, like we're making a peanut butter and jelly sandwich or something. The goal is just to provide a very thin layer so we can have more efficient thermal transfer between the two devices, and so we can kind of fill in all those gaps and holes, because those gaps and holes and imperfections in the metal will lead to inefficiencies in cooling. So that's why I use it. Now, let's talk about applying thermal paste. This is a hot topic, and listen, I can already hear you thinking, I know. Your uncle's neighbor showed you a video on YouTube, and the guy there, did a little X with his thermal paste, or maybe he drew the flag of Macedonia or something. That's great. I'm happy to hear that, and I'm glad it worked out for them. And I'm not saying that in general those methods don't work. But what I'm saying is, if this is your first time, if you are a novice, the only method that I can suggest is the Intel method. So we're going to include this up in our resources for you, as usual, but Intel has a great page here, and if you haven't figured it out yet, Intel kind of knows a thing or two about CPUs. You can look into a little thing called Moore's Law, but they've been doing it for about 60 years now, so they're very, very good at it. They have an entire page here on how to apply thermal paste, why it's needed, the different components of everything, and how it actually works. Plus, they actually show you what I'm talking about here. So we can see that on the CPU, even though it looks to our eyes to be flat, there are millions and millions of little imperfections here. And that's the goal of the thermal paste. The goal of the thermal paste is to kind of make those two layers into one, using as little thermal paste as possible so that we can fill all those gaps and have more efficient thermal transfer. So this is a very good site. And if you scroll down here, it recommends, let me find it, pea-size drop, somewhere in here. Here it is. Thermal paste, roughly the size of a pea or a grain of rice. Now, if you don't, offhand have any peas, like I forgot to pick some up this morning, some frozen peas, I kind of use some stress putty here to maybe make one that's about the size of a pea, give or take. And I always suggest too, if you're just starting off with thermal paste, before you start spludging it here onto the CPUs, because remember, any overages, especially if you're using some of that high quality, like liquid metal based thermal paste, even just like a tiny, tiny drop of that gets into your CPU socket or onto your motherboard can cause some serious shortages and kill your equipment. And if you've never applied thermal paste before, you can actually practice it at home. It's quite easy. You can grab some index cards, and it's really quite simple. What I'd suggest is set a frozen pea or some stress putty or something similar up next to it, and do your glob. And if you're unsure if it's pea size or if it's enough, take a little foam block, a little piece of wood block, a piece of plastic, something square like that, and you can actually simulate you putting the heatsink on. And you push down and you pull up and you can actually see the actual coverage area. So it's easy to practice until you get the actual right size for the CPU, until you get it down pat. So I strongly recommend doing that. Now, let's have some fun. Let's talk about what happens if you go a little overboard. Remember I told you that one type, of thermal paste can actually really cause some damage? Well, let's look at some of these other methods that get recommended. Let's try the X method. Okay, really hard to get the exact amount here on the X method, but let's hope that's about right. And if we smash our little block down in here, we can clearly see that we have thermal paste coming off the sides, all over. We don't want that. That's not good. We also don't have even coverage either. So while, maybe someone's gonna comment on my technique with the X method, but it definitely does not provide even coverage. So again, you can practice with yourself. This is an old CPU. If you don't have one, just use note cards, use a pea, a couple grains of rice, whatever, and smash it down and get used to it. Eventually you'll get the perfect amount. Now, if you have done a little bit of excess thermal paste like I have here, and this is your only CPU, or you make a mistake your first time, it's okay. They make little cleaning kits like this one, where you can get a bunch of different types of one liquid to remove and one liquid to purify. You can also just use regular rubbing alcohol, 70% isopropyl alcohol, and a Q-tip or something, and that'll clean it off. But it's actually quite simple. Since we don't really care about this CPU, this is a dead one, I'm gonna demonstrate with 2 big drops. And I'm gonna take this CPU, and I'm gonna take my handy dandy paper towel, and I'm just gonna wipe it off. And make sure that when I wipe up and out like that, because I don't want to get it down into the grooves or anything. And it needs a little more. You can see I definitely went sloppy with that X style. I'm sure I'll get some emails on that. All right. And there we go. So we've cleaned off our CPU. At this point, if we wanted to, we could go ahead and purify it with our second solution. And then it's ready for us to apply more thermal paste and try again. All right, one other thing we have to talk about is thermal pads. Thermal pads are used a lot of days mostly to replace the pre-installed pads that come with a GPU, right? Because a lot of times those pads aren't quite as efficient as we'd like them to be, or we're running our GPUs under really, really heavy in strenuous environments. And so we actually have these little thin thermal pads. They're made of possibly copper, silicone, wax. I've seen them made of all sorts of other things. And they just honestly replace the factory pads in there. Now, the final thing, and I have to admit, I'm going to show you this is my preferred method of cooling. This is my CPU cooler at home, a Noctua DH14. I love it. I've used Noctua forever, but that also means that I'm an air-cooled guy. Listen, air-cooled fellas, I hate to tell you this, liquid cooling is much more efficient. Now, I personally like to stick to air cooling because the coolers that I use aren't loud, so that doesn't bother me. And if a fan dies, right, nothing's gonna die in the heatsink, it's just a big hunk of metal. And if a fan dies, I can easily replace it. But with liquid cooling, if we look over here, and so with liquid cooling, if you look, it looks a little bit different. We have some fans here for our case cooling and some of the other components, but for the CPU, we actually have a pump that's built in here into the cooling mechanism. And this sits directly, instead of a heatsink, on top of the CPU. And it runs a liquid that's typically made out of water and some alcohol mixed in, but it can come with a couple other things. And it has these connections here that actually pump to and from, pump the cool liquid in and the hot liquid out, and then they come across this radiator or water block right here. We can see right across the top. And those fans actually cool it, the same mechanism that's in place with heat sinks, right? We have more of we have more surface area for the fans to cool it. The water runs through there, gets cooled, comes right back into the loop, goes to the CPU, and it repeats again. So it's much more efficient than air cooled. I've fought it for years, but I promise you, if you're an air cooling fan, you switch to liquid cooling, it is much better. It's more efficient thermal transfers, it's cooler cases, and it's less noise. So definitely check out liquid cooling. But there you go. We have fans, we have heat sinks, we've learned how to do thermal paste, and we have liquid cooling. Now you know all the ways to keep your system cool and running hassle-free.